Right, okay, I think we're going to make a start. So, afternoon, everyone, and welcome to the Applied Environmental Robotics Training Free Information webinar. Just as a quick introduction, my name's Libby, and I'm the project manager of the Scientific Robotics Academy at the Scottish Association for Marine Science, and I will be taking you through this short webinar. But first, I just wanted to say a huge thank you for joining us today, and we're really excited to share with you some training opportunities coming early next year. So we have an exciting agenda planned for this next 90 minutes. So what we'll first do is have 5-10 minutes to learn about SAMS and the Scientific Robotics Academy. You'll also get to meet some of the field experts who have designed and deliver our courses, and who will outline what they do and what they'll teach you throughout the courses. And I've also tasked them to highlight how AI robotics will change environmental monitoring, or they can also highlight one particular breakthrough that they think has been transformational as well. So they'll cover that. We have two upcoming courses in March 2026 at our world-class teaching and marine research facility, which are the perfect opportunity for you to grow your network and foster collaboration and gain hands-on experience in in-demand training with a variety of current and emerging innovative platforms. So you'll learn about these training opportunities, as well as learning about funding opportunities to support your participation in our training. And then at the end, we'll have a Q&A session for you to ask any questions that you have. Just so you know, the session will be recorded and will also be made available on our website, the Scientific Robotics Academy website, after the webinar. And please also do use the Q&A chat function throughout the session if you've got any questions. And then what we'll do is answer them at the end of the webinar session. Right, we'll get started. So, first things first, SAMS. So, you might not have heard about SAMS before or visited SAMS. So it stands for the Scottish Association for Marine Science. And we're based on the west coast of Scotland in Oban. We have three pillars at SAMS. So first off, we have teaching, where we are partnered with the University of Highlands and Islands to deliver bachelor's and master's degree programs. So that's this kind of building to the left here. We also have a research kind of pillar where we deliver cutting edge science working across a global network to create innovative solutions and monitor our changing planet. And then lastly, our third kind of pillar is our SAMS Enterprise group, which Enterprise is an enterprise is where the Scientific Robotics Academy sits. So it's a wholly owned specialist marine consultancy where we deliver a variety of commercial projects, which then feed back into the research at SAMS. So in terms of this illustration here, it shows that there is a huge variety of expertise at SAMS who specialise in a wide range of topics, including ocean currents, marine mammals, marine energy, aquaculture, and of course, we have robotics right here, which we'll be focusing on during this webinar. I'm going to pass on now over to our experts who deliver our training. And as I said, what they'll do is just have a 5-minute introduction each, quite quick fire into what they do, what they'll teach, and also answer that question from before. So I'll pass on over to Phil, if you want to unmute yourself.
Okay, hello everyone. Yeah, thanks Libby for a wonderful introduction as ever. My name's Phil Anderson. My background is atmospheric and polar work, and you see there measuring atmospheric and marine physics. There's a whole host of non-physics people in this team as well, so I'm taking more of a historical look to lead in. What I would teach you is how to select what data you need for your purpose, and that is the first step in the way of designing your platform systems, and then how to select the suitable platforms for that. Going to dip a little bit into history. because I can. I've got the grey hair to do that. Back in 1969, at the very limit of technical capability, 2 humans walked on the moon. 30 years later, however, looking at Mars, it was a robot called Sojourner was the first moving thing that we sent to Mars. Humans were far too squishy and expensive to send all that way and were difficult to maintain. But in 69, there wasn't any alternative, but now there is. So Sojourner was a phenomenal success. Not many people heard of it. They heard of Pathfinder, perhaps, but Sojourner was the first. And in the following decades, robots are still very expensive, and they're mainly there to do what we say the dull, dirty, or dangerous tasks that warranted their cost. But by 2000, 2 milestones, one in the ocean, one in the atmosphere, had been covered. In the ocean, ocean gliders and Argo floats were now able to take measurements of the ocean currents, which were really not understood at all in the oceanography side. And open source avionics for atmospheric robots or drones, fixed wing and copters. They allowed even meteorologists to be able to afford to get up into the sky and measure stuff that was still unknown in the atmosphere. And that opened the door, doing the dangerous stuff, but also just the dull stuff, doing very, very repetitive survey. And from the perspective of environmental science, oceanography and meteorology depended significantly on measurements actually in place. We call them in situ. Satellites can't see what the air's doing, and satellites really can't see what the ocean's doing under the surface. Satellites are very good at seeing clouds, very good at measuring ocean surface temperature, but to get much more information, you actually need to be up there measuring what's going on. So following on from that, there was more reliance on collecting data at a distance. And so this led on to a revolution really in Earth observation, which you're probably more familiar with, looking at the surface of the planet, not just seabed, but also the Earth itself, where we live, using mobile cameras on drones. So everybody's seen the quadcopters with a camera. This Earth observation really did revolutionize our view of robotics. And it's much more related to collecting data at a distance. So we call that remote sensing, and we'll cover that also in this discussion. So one of the things we're throwing in is AI and robotics, because these systems now generate an overwhelming number of data. It's vast, terabytes and larger, and it's impossible for humans to really grasp all the aspects from fine detail up to overall view when we're gathering these data. So AI is becoming an essential tool for collation and analysis of these data, and to get the understanding of what is being looked at actually in real time or near real time, as opposed to 3 or 4 years later once you've done all the analysis. So that's a bit of background. As I say, my background is much more in fluid dynamics, physics, and mostly in the atmosphere and polar regions. But I try and be a generalist when it comes to just what robots do, why we use them. I'll hand back to Libby at that point, unless Libby's got a question for me to carry on or something. But yeah, I'll hand back to Libby.
No, that was brilliant. Thank you very much, Phil. Thank you. Okay, we'll move on to Joe.
Hi, yeah, I'm Joe. I'm a postdoctoral researcher here at SAMS. I'm a benthic ecologist by background, having worked a lot previously in the tropics and for a fair bit of my time in Antarctica. But my main job actually at SAMS is looking at what we call marine growth. So that is the benthos, the kind of seabed life that grows on the sides of offshore structures. So wind farms, oil and gas platforms, but I also do work on other kind of vertical habitats, if you will, doing lots of work in fjords in Greenland. And to do that, a lot of my background has been on using diving, but diving is a slightly dying art in science. because again, as Phil says, we're squishy and prone to having accidents underwater, whereas it's far less consequential if it's a machine that has those accidents. So I do a lot of my work these days is using remotely operated vehicles, so ROVs. A lot of the technology that has come in recent years from aerial drones has now been transferred into underwater vehicles for ROVs, and this has been a real kind of step change for environmental monitoring, because these things are cheap and actually very effective, and can go down to depths and stay longer than humans can. So we've invested a lot of energy at SAMS into deploying and understanding ROVs and attaching various instruments to them. We've learned some hard and expensive lessons along the way, so hopefully we can pass on that knowledge to you so you don't repeat it. So we use a lot of ROVs and also a lot of image analysis. I work very closely with Dr. John Halpin, who'll be talking in a bit. So we use photogrammetry and machine learning to do a lot of our work. So as part of the course, what I'll be teaching you is kind of ROV operations, what to consider if you are potentially buying one and then operating it. And then actually for the photogrammetry part of these courses, everything from how to acquire your data, how to process it using some common photogrammetry pieces of software, and then the various analyses you can do afterwards to actually make it meaningful. Yeah, and that's me. Back to Libby.
Great. Thank you very much, Joe. Really appreciate it. Right. We will move on to Phil Peterson.
Hello, everybody. I'm the robotics engineer at SAMS. I build the robots. My work typically involves coming up with various contraptions to assist the scientists at SAMS and a variety of other things for SAMS Enterprise, just doing supportive engineering work, as well as training and STEM outreach. My major objective in teaching these courses is to give you a proper grounding on how to cope with the jargon and other unpleasantness of technical information that goes with any new technology. We're not so arrogant as to think that we can teach you how one of our specific platforms works and that'll make you an expert in everything. Although we will be teaching you on these courses, like just directly how to operate robots and the kinds of things they can do. But I also want to give you a grounding on like what a data sheet is actually saying to you, what a power supply is actually doing, what its statistics mean, what the assumptions that you've got to make, like a grounding in engineering architecture for these systems, and then you'll be able to go on and make use of that information in your own research work and deployment work using these platforms. Yeah, I guess that's pretty much all I can help with at the minute.
Great. Thank you so much, Phil. Thank you. Okay, right. We'll move on to Petra.
Hello, everyone. I'm Petra. I'm a robotics and ocean mapping technician here at SAMS. So I'm a part of the Scientific Robotics Academy team, but I'm also part of the SMRF team, which stands for Scottish Marine Robotics Facilities, which we actually have these facilities when we have different variety of the underwater robots, from as Joe mentioned, from ROVs to AUVs, so autonomous underwater vehicles, such as Gavia. We've got also sea gliders, so I'm a part of the sea glider piloting team here at SAMS as well. And I'm a technician, so super scientist, so I do support the scientists across. I specialized in seabed mapping, so surveys, and also the data processing from multi-beam systems and side scan sonars. As I mentioned, so I do also operate a variety of the robots, including multi-beam systems, side scan sonars. And during the course, so I will give a presentation on the underwater aspect, because I don't know if you mentioned, so also in this course we kind of going from the aerial to the surface, and then also we moved to the underwater robots, because they're quite similar. So, you know, and then also some practices you're using across the aerial aspect, the environment, you can also apply on underwater. But there are also there are also different things to consider, as it's a different environment, also the sensor integration. So yeah, we will learn through all these different aspects as well. Also, we will touch the calibrations and data quality, also because when you're starting your project, you also have to have in mind what the data going to be used for. I mean, are you looking for the high quality data? If you're looking for really high resolution data, are you also looking for machine learning? So to be able to identify some of the features that may be repeated over the period of time, or you can also yeah, or you're just looking for the data that doesn't really have to be so high resolution. This also affects the time of the preparation, for example, the cost. So we go over this as well. And then also there is a practical aspect in this course as well. So which we would look at risk assessments, some of the data sheets that Phil Anderson mentioned, but so kind of looking at the different instruments as well, and then it's more having a discussions around this. Very looking forward to meet you all in person. Sorry, I can't see everyone, so but that would be me leading on underwater sensors, calibrations, and some risk assessments and other things.
Great. Perfect. Petra, I've got a question. Just a
Okay.
quick one. Well, it was the about how AI robotics will change environmental monitoring. What do you think about that? How will it change
I mean,
environment?
I'm not sure about, I mean, the sensor integration. I mean, we can look at the, you know, because if we're looking at the high resolution data, so we're gonna end up, especially if we do, for example, I mean, I can talk about the seabed mapping. So if we do the seabed mapping, so it's quite big data we can collect. So, and then also the post-processing, it can be time consuming as well. So maybe with the AI, we can look at some integration, or maybe some kind of speed up the processing and overlapping with the imaging. For example, when we occur from the ROV, looking at the integrating navigation, so which can help speed up the process. So
Great.
yeah,
Yeah, great. Thank you very much, Petra.
you're welcome.
Right, we'll move on to John.
Hiya, I'm John, and I'm a marine image analyst and modeler. What I do, so I simply answer biological questions using imagery. As you can imagine, so improving technologies in data collection, that's both cameras and platforms, is giving us an ever-increasing amount of visual data, and that amount of data we're collecting kind of exceeds our ability to analyze it by hand, both in resolution and spatial coverage. But a solution to this is AI or machine learning aided image analysis techniques. A couple of the projects that I'm involved with, so I work with Dr. Joe Marlowe on mapping marine growth on structures across the North Sea using AI and 3D modelling. This is a really interesting project. It's generated lots of commercial interest. Also, I don't know how many of you have heard of flapper skate. So they're a critically endangered skate that they're glorious things. They live off the coast of Scotland. Each skate has a unique spot pattern, and we've developed an algorithm which is essentially facial recognition for fish. So now when a picture of a fish is sent to us, we can give the name of that fish to the person that caught it, which is great. So what I'll teach you, simply how to extract useful metrics from imagery collected using a range of different platforms, using kind of the latest techniques. So I'll give you experience with the current and emerging innovative tools in image analysis. And yeah, looking forward to meeting you all. Thanks.
Great, thank you very much, John. Okay, we'll move on to Rich Dale.
Yes, let me thank you. So I'm Rich. I'm basically a senior drone pilot. So I've been at SAMS now for 15 years, and I've kind of headed up our drone operations pretty much for the last 8 years. I've been involved in like drone robotics for the last 17 years. Did flying for National Geo and all sorts of other places in the past. As Neil, who you'll hear from, I think, as well soon. We were probably in the very start of this when basically drones started becoming a thing. To us, they were just remote controlled aircraft at that point. So we've been in it for a very long time. And for that now, I basically look after all our operations. So all the safety aspects, all the regulatory kind of things that go along with it. It's not just going out and flying anymore. There's a lot of regulation that comes into this. So for the last while, I've sat for places like CA Advisory, and not just UK, across Europe, and the Arctic, Antarctic as well. So there's a lot of things that go into this when you're planning missions. I look after all that stuff, keep us safe, keep us compliant, and all that kind of thing. So what we come to the actual course, my kind of background is in the science world now has been to basically fitting sensors and making sure we get the right sensory platforms on the actual aircrafts, how that integrates to the actual aircraft, how the aircraft flies safely, and how we test all these things to make sure we're covering all grounds. There's a lot of these things, we have it a lot where we've got a one-off sensor or a very expensive piece of kit in the air. We want to definitely make sure that comes home to us, and we want to make sure the data is actually of high value and it's like used to everyone. So that's a lot of the things I will be covering on the course for you, as well as things such as risk assessments, mission planning, all this thing, all safe protocols that we're going to go through, as well as integrations of robotics across the whole board. There's a lot of wide range of things I'll be covering, but most of it will be regulation from my side, unfortunately. So back to Libby's question, the AI side. Where do I think we're going to be, especially for anyone who's coming to this course, quite an important one is where we're moving at the moment is AI becoming a huge change in this field, where we're looking at more integrated flight. So we're looking at things where we can send aircraft out on their own. They can start to predict things. There's no human in the loop as such anymore in some of these operations. So we've been looking at things like how that can happen and what the future of that's going to look like. We're definitely stepping into this, like Joe and John and other projects we currently have going, is looking at how we integrate real-time AI into our aircraft. So no humans in the loop. And as Phil said at the very start, they are doing the dirty and dangerous for us where we don't want to send humans. I think that basically covers me, Libby, and what I'll be teaching.
Yeah, no, that's really, really good. Thank you very much. Thank you. Okie dokie. Well, last but not least, we have Neil.
Thanks, Libby. I'm Neil Burnside. I'm a senior lecturer in biogeography and geoinformatics here at SAMS. I suppose one of the main areas that I work in at SAMS is the use of UAVs and ground surveys for restoration and monitoring. So how can we look to deploy these systems to gain an advantage in developing our understanding of the success of restoration or the potential of where restoration can occur? So I really do sit in that area of sort of geoinformatics, GIS and remote sensing. We're fortunate at SAMS, though it's the Scottish Association for Marine Science, we work in the coastal, marine and terrestrial sectors from a conservation perspective. And you've all already met Rich, but Rich and I will, work with clients, with research partners to see how we can use UAVs for nature-based solutions to speed up the process, make it more efficient as an approach. Some of the UAV operations really focuses on a sort of multispectral and hyperspectral imaging. So with multispectral imagery, we're able to go beyond the visible spectrum into parts of the electromagnetic spectrum that we can't see. But they can be very useful for perhaps discerning different qualities in vegetation, or it could be mammal species even. Because some of those plants interact with different parts of the electromagnetic spectrum in different ways. So we can end up identifying down to a community, in some cases to a species level. So this is a real opportunity area. I think a breakthrough for us is this. We've been playing with multispectral data for decades now, but this ability to move into a hyperspectral realm is very important because we can get very, very narrow bands, and potentially we can start to fingerprint particular features, objects that we want to identify. So I think that's a transformational area at the moment. But equally, as many of my colleagues have said, the fact that we've got AI and we've got machine learning, we can deal with these big data sets, and that's a key area. What I'll be involved in is looking at how you might integrate UAVs, remote sensing, image analysis into your conservation and restoration interests. We'll offer practical and theoretical learning in the use of UAVs for these purposes. So within the programs, our aim, Richard and I, is to try to get you hands-on with the systems, but thinking about how to design a robust, reliable, repeatable survey so that you can do these temporal studies, but equally how you can capture imagery data that actually is really meaningful through calibration of the data in the correct ways. So as the others have said, I look forward to meeting you, and yeah, all the best. Thanks, Libby.
Great, thank you so much. Okay, fab, we'll move on. So now you know a bit more about our team, we're going to move on to the exciting courses that we have coming up in March 2026. So first up, we have an environmental monitoring using autonomous platforms course, and that's being held at SAMS on the 16th to the 18th of March 2026. This is a CPD recognised course through IMAREST, and it is designed as an end-to-end introduction into the capability and use of robotic platforms, including aerial vehicles, sea surface vehicles, and underwater vehicles for environmental monitoring. So alongside peers, across 3 days, you will handle a wide variety of platforms and learn about their different applications, practice developing a mission, advance your understanding of sensors to integrate into these platforms, learn about key regulatory considerations for operating the equipment, and also practice some data processing with some pre-collected environmental data. As Neil said, there's a blend of theoretical and practical learning. So that will provide you with extensive opportunities for you to discuss your objective with both peers and staff, so that you can leave the course with a clear and immediately applicable action plan for utilising these technologies safely and reliably. So yeah, bookings are live as of today. You've got the exclusive kind of launch of this. So yeah, that's our first course in March. Next up, to kind of follow on from that, we have our 2-day advanced photogrammetry and data processing course. That's also being held at SAMS on the 19th and 20th of March. So just in case anyone isn't familiar with the term photogrammetry, it is the use of photography to attain information about physical objects and the environment. So this course is designed as a natural follow-on from the 3-day course, and it delves deeper into the use of photogrammetry and data processing techniques to produce robust, repeatable, and reliable environmental data. So yeah, during this course, our experts will take you through each step of processing real data collected by our ROVs and remotely piloted aircraft, as in drones, highlighting exclusive tips and tricks gained from their own experience in the field. So by the end of the course, you will know the key considerations and have gained extensive experience extracting reliable measurements from photography captured in aerial and subsurface environments. So that's our advanced photogrammetry and data processing course. And again, bookings are live for that now. So we'll move on to funding opportunities. One thing we have, again, it's just launched, is our part sponsored places. So we've received sponsorship from Nadara. So thanks to them, we've been able to offer these places. In the previous two slides, you saw that there were kind of full cost prices for each of those courses. You can do those separately if you want to. However, as I said, the second course is kind of a natural follow-on from the first course. So we are offering a 3-day and 2-day combined kind of discount to attend both courses, and it's a 30% kind of discount for those. We have 10 of these part sponsored places available in there that you can go through. You can either scan the QR code there to find out more, or just go straight to our website, and it will be kind of a first come, first serve basis. There's only 10 places available. You can apply for multiple of these places from the same organization if you wish as well. That's absolutely fine. But we do have those 10 spots available only, and once they're gone, they're gone. So yeah, that's just one opportunity if you want to apply for that. And also, just to be aware, you don't have to be in a particular role or be a student or anything like that. You can come from any background and apply for these funding opportunities. Other funding opportunities, I just did a bit of background research into what else might be out there to kind of support your participation in these courses. So it might be worth just checking out these websites and seeing what's available. Some of the things, for example, UKRAS Conference and Training Funding Scheme. I saw that they have just funding to spend on training for UK-based research technical professionals, and the spend is before September next year, so it'll be quite a good advantage there as well if you're interested. UKRI, they have a funding finder kind of thing on their website, and you can also subscribe to their emails for any funding notifications, so that might be also an opportunity there. Scottish Enterprise, that's a good opportunity. Find business support. I think this one is more directed towards businesses supporting their employees in then kind of receiving training. So if you are an employer, or you want to kind of approach your employer and say, look, this funding opportunity is available to support training, then that might be worthwhile looking into there. Also, Highlands and Islands Enterprise, there's on the website, there's a list of kind of funding opportunities available, but they also kind of, there's information available for you to reach out to them and inquire into whether there's any particular funds available to support any kind of training. And there is also a newsletter as well that might be worth signing up to as well, just so you keep in the loop of any opportunities available. And last but not least, obviously, if you're a university student, there might be an opportunity to kind of explore student bursaries, see if there's anything available within your university to kind of support your participation. So that's that. So we have got through this very efficiently. So our CPD recognised courses are the perfect opportunity for you to grow your network, gain hands-on training with a variety of current and emerging innovative platforms, use real-world case studies at a world-class teaching and marine research facility. Designed by the field expert you've met today, our courses are designed to upskill you in in-demand skills that will empower you to make more informed decisions, avoid costly mistakes, enhance your CV, and build your confidence. So that was kind of our roundup, and I'm very much opening up to kind of Q&As. I don't know if anyone's got any questions at all. I don't see anything in the Q&A panel just yet, but if you've got anything, feel free to type them in just now. If not, that's absolutely fine. I have, oh, here we go. Right. What monitoring would you suggest for cold water corals? Anyone from the team, maybe more Joe, John, perhaps? Petra, would you?
Should we take this one, Joe?
Yeah, sure. So we certainly do work with cold water corals, because a lot of the work that we do on offshore structures in the northern part of the North Sea, there are Desmophyllum petusum, which used to be called Lophelia petusa, cold water corals, and we use a combination of photogrammetry and machine learning to do that. So we create 3D models. John's got a bit of coral in his hand there. Yeah, we use ROVs to take video or image data, create 3D models, and then we use a machine learning pipeline that identifies it. So basically, it kind of colors all the cold water corals in our 3D models, so they can be quickly isolated from the background. And in terms of monitoring, the nice thing about photogrammetry is it's repeatable, and if you've got geo-reference data, so you know where your imagery is coming from, you can actually basically kind of align it year on year, or however regularly you're doing your monitoring, to see whether your coral is growing or eroding, or whether you've got recruitment. But that's a kind of general answer. Obviously, it's a very case specific requirement for each kind of for your requirement.
Great, thank you very much. Okay, we'll move on. Grace has asked, what software do you use, please? Is this, maybe this is just generally as well, maybe we should go through kind of from underwater to aerial. So John, Joe, do you want to start?
Well, we have a specific software. I guess, but we use the ROV a lot. We use a Blue ROV, which we use Q ground control, and latterly Blue Robotic Zone software to control it. In terms of photogrammetry, we use Agisoft Metashape, but we're starting to transition to potentially using Zephyr. At the moment, Agisoft is still the best software, and we've had our licenses for a long time, but they are a Russian company, so lots of people are moving on to different organizations. It's unfortunate because Agisoft is very good. John can talk about the machine learning side of things.
Sure. Before I do that, so I've just posted a link to our workflow for cold water corals in the chat if anyone wants to see the output of that. So yeah, for machine learning at the moment, everything we use is kind of custom scripts. Like it's not point and click software. It's our own kind of code in Python, but all using kind of open source libraries and so on. But yeah, we can teach you some of this.
Great, brilliant. Phil, have you got anything in terms of the surface vehicles, like any particular software?
I'll just chip in if I can. So one thing I do is use these surface vehicles. You've seen a few pictures of them, little kayak with instruments on the top, and we also use aircraft. So what we're doing is seeing how small scale weather models, 100 km² weather models called WRF, and we are using this in the Hebridean areas to try and understand forcing on aquaculture. But we're well aware that they're not quite working perfectly. Weather forecasts don't. So we use WRF as our weather forecast model, which we run in SAMS, and also oceanographic models. And then we're just using standard MATLAB or Python to do comparisons between model and data. And that'll give us indications and hints of what physics we're not quite getting right yet. So this is really back into the physics aspect. and we write our own scripts and coding to do that sort of work, and always has been thus. It used to be Fortran, now it's a bit nicer. So that's on the physics side. I'll hand back to Phil Peterson if he's got any other comments.
When it comes to robotic control, we use the open source platform of the ArduPilot and related software. So Q Ground Control is one ground control piece of software that works with ArduPilot. We also use Mission Planner, which is an alternative. It's more flexible when it comes to configuring these things, but you can't control groups of them as easily. But that's the ecosystem that we're trying to push our more developmental work in. When it comes to rolling your own electronics or incorporating more exotic sensors or things that might require a bit of feedback, you'll generally find that DJI, which produce excellent drones, can be very restrictive. If you're doing something that's outside what they'd considered when they were developing it, it's possible, but it is restrictive. So we're making use of a rapidly developing ecosystem in ArduPilot, and we'll hopefully continue contributing to that in future. Sorry.
It's all right, Phil, don't worry. Thank you very much. Neil or Rich, do you have anything to add from the kind of aerial side?
Yeah, I think your question, Grace, was what software do you use? The software, I mean, I concur with Joe's point that Agisoft is very, very good. It is the software system I've used for the longest, but it's become a complicated landscape. That said, Pix4D is also a very, very good software system for this, if we're talking about photogrammetry. But Zephyr, I've heard reports, I haven't used Zephyr extensively, but from other researchers that I've worked with, they've said that actually some of the orthomosaics that are produced by that are amongst the best that they've seen. So I think what we'll probably find at SAMS is that we'll start to explore some of the others, but they're all very good. But I do agree with Joe that Agisoft have been excellent, and the staff at Agisoft, if you have any support queries, are fantastic in resolving those support queries, technical questions. From a machine learning side of things, I'm often find that the systems that I use may be dictated by the people or the organizations that I'm working with. So lots of the industry standard software systems now, like ArcGIS, have very good AI within them. The deep learning within it, it's a little bit clunky with some of the extra extensions to the software that you have to add, or libraries that you have to add, but it does do a very good job. So as I say, ArcGIS is very good, but also John's sort of directed me to some open source software systems which are out there as well, and there may be some examples of that. There will be some examples of that open source software that we could bring into the course if people are interested. And the same goes for QGIS as well, which is obviously open source and does have some good machine learning routines associated with it.
Great. Thank you very much. Okay, we'll move on. So Igor, nice to see that you've joined us. So you've mentioned is photogrammetry course going to be year-to-year workshop, or did you envision it to be only 2026? I'll probably take that one. So depends on demand, honestly. Obviously we want to try and run this at least once a year. Yes, we are looking at trying to deliver more courses in August next year as well. But again, it depends on demand as well, because this will be the first time we run the photogrammetry and data processing course. So we're just going to see how that goes. But the vision is that it will be at least once a year. Yes, yes. Okay, Dave, you've said I have a few years experience with designing and operating robotics indoors and in very basic outdoor settings. I am more interested in learning about the measurement side of things. Which of the two courses would be better for me? What do you think? Any kind of comments from the team?
Again, I'm happy to tip in here if I can.
Yeah.
Hello, Dave. Yeah, my background is also designing instruments for the measurements I want to take if they don't exist yet. So we do have some of the sensors that we develop here and package them up and put them out, and have had deployments up in Arctic and Antarctic regions. So the question really is stepping back a bit. In the world of our science, you start off with a hypothesis or a model which you want to test to see if you're anywhere close. That needs data. To get the data, you need your measurements, and to get your measurements, you need your instrument on a platform. So that's the story. We'd just throw it back to you. What do you want to measure? What are you trying to test? What do you think is not certain in our corpus of knowledge? And from there, you look around, see if there's one already available but has never been deployed on a robot, or in certain cases, nothing exists yet. And that's when you're at the really exciting but not very productive stage of science. You spend 3 years and get one measurement. So it's an open question, but we're very much, I'd be very keen to talk about the pure philosophy of science all the way up to how do you do good soldering in the lab. And we cover all those areas. So yeah, please come on. I'm happy to have that sort of chat. Anyway, absolutely.
Yeah, Dave, if you want to email us with a bit more details about what you're looking to measure and in terms of like what actual platforms you've used already, and what you're looking to kind of what your objectives are for the training, then we can provide a bit more information about what would be best for you. Absolutely. So yeah, the email is just on the screen as well. So yeah, feel free to pop us an email and we can chat separately about that. Igor, you've said, do you also work with multi-beam sonar data for environmental monitoring, for example, ROVs? There is a lot of interest from my institute on the applicability of such technology for fish population studies and habitat classification. The subsurface team, you might be able to answer that one.
Okay. Well, thanks for the question first. I mean, for the multi-beam system sonar, I mean, at the moment, I mean, we do using, so we have a multi-beam system on the autonomous underwater vehicle. We don't have anything integrated at the moment into our ROVs, as because for the ROVs work which we have, so we're more looking into the high resolution video for photogrammetry 3D models, but we do use the multi-beam system and not really looking into the fish population studies, but yeah, surely for the heartbeat classification. So also because with the autonomous underwater vehicle here, we with the multi-beam system we get closer to the seabed, which gives us the higher resolution data. We can also survey a bigger area much quicker, and then and then we can identify some of the habitats which might be closely related to some of the fish population. Like we were also using the multi-beam system with the skate population when we mentioned, I think John mentioned it as one of the projects. So they were also we were using also the visual, the ROV footage, but also the multi-beam to identify the best habitat of this fish population. Yeah, so we do that. I mean, this is something that multi-beam can be easily integrated to ROV. So, and then while you're taking the footage, you can also collect multi-beam data, which later on you can overlap them. Yeah, this is something, I mean, it can be done, yeah, but here at SAMS, we're using the autonomous underwater vehicle, not the ROV for multibeam. I hope I answered the question. Anyone else wants to? I'm John and John.
I think, yeah, we would just say that, so John has a PhD student who is integrating imagery and multi-beam data in multimodal machine learning, and we are certainly considering getting a multi-beam for our ROV. John, do you want to add anything? You're on mute.
Sorry, just to say we've got a workflow for habitat mapping using a multi-beam on an AUV combined with imagery, and it does a really nice job, because if in any cases the imagery is degraded, the kind of neural network design it uses, can you sort of rely on the multi-beam in those cases and still return an accurate result? So it's a good way to go.
Great, perfect. Thank you so much for that. Okay, we'll move on to Javier. So he says, hello, thank you all for the info. In the second course, the photogrammetry one, will it have some teaching on how to use machine learning applied into the 3D models, like for volume estimation or species count? And then you go on to say, do you mask the corals in the 3D model manually, or is it using machine learning with trained data? Joe,
Yes. Sorry, there's quite a few parts to that question, weren't there?
sorry, yeah.
That's all right. Yes.
We'll split it.
We will certainly. I think we're going to have the time only to delve into some basic machine learning, but we will certainly go over how to incorporate machine learning outputs into the photogrammetry process. So yes, we do actually mask our corals using the machine learning outputs in photogrammetry directly. We don't do it manually. We use machine learning because we have kind of large models of say an oil rig with lots of different coral bommies all over it. To do it manually would take forever. So we use machine learning to do that, and we will be using data sets like that example to go through how this is done. I hope that helps.
Yeah.
John, did you want to add anything to that?
No.
Spot on, Joe.
Yeah.
Great. Thank you so much. Are there any final questions at all from anyone that's joined? I know it was an information overload there, so no worries at all if you want to kind of reflect a bit on everything and email afterwards. I'll just give a final few seconds. No? Okay, right. I think we'll pause it there. As I said, if you've got any other questions at all, please don't hesitate to reach out. We have our email on the screen there, and also we've got our LinkedIn page as well. So, and we'll be posting updates on there. Just feel free to reach out through either of those, and I'll be back in touch with you there. As I said, bookings are live for our courses now, including those part sponsored places. So if you want to join, make sure you get those early. Yeah, thank you very much to yourselves for joining. Thank you very much to the speakers for taking the time to join. Obviously this recording as well will be made available on the website afterwards. So yeah, thank you very much, and I hope to see you on the courses. We'll see you later.
Thank you.
Here's everyone.
Thank
All the best.
you.
Bye.
Thank you.
You're on.